Ladies and gentlemen, welcome to another episode of The Voice of Neuro, I guess. This is a conversation about disease, vaccines, disease resistance, cat ears, and mating with aliens. Probably. Welcome, the esteemed guest, codename Sir William. What's up, dude?
Hello.
We did the intro. The chat has been spiced up. You can see the temperature rising a little bit. So let's get some context for the conversation. So you are someone who is learned in these ways. I talked about science as like effectively wizardry, where to the average creature on Earth, they don't understand a lot of these chemical reactions and the things that aren't visible to the naked eye. But if you are rigorous enough and you study and you build enough, you can achieve some pretty zany stuff with science. And we have some germ theory, we have some disease, things that are effectively invisible to us that have caused a massive problem over time. You study this stuff, and you said you watched some StarCraft guides during the quarantine, and that was the bridge.
Yeah, I was a gamer, I guess, in a former life, and then thought, I don't have time for this. I gotta, I don't know, be busy in college. And when I was getting my PhD, I kind of fell off, and then the quarantine was a great time to play games with my family, and hang out on Discord and get back into uh, things that fundamentally make me happy. So here I am, hanging out in the Neuro stream, um, watching way too much StarCraft, and playing probably not enough like every other good Twitch chat GM. But it's been great to kind of bridge my old life and my new life. But I will be honest, I was hanging out, really enjoying the Agent Smith discussions that you host. But whenever the conversation turns even remotely close to science, and especially vaccines and coronavirus, um, I I can feel my skin start to tingle a little bit. And this is a really awesome opportunity, and I'm really grateful that you've given me a chance to, I guess, talk to Twitch chat a little more directly. And I'll do my best to answer the genuine questions and, if possible, maybe confront a conspiracy or two. But I don't know how much I want to go down that road, because ultimately those people might just need to do the experiment themselves.
Yeah, so for my perspective on this, I haven't studied these vaccines to great effect, so a lot of the banter in the chat, I don't really have any scientific background or a heap of study to kind of tell them how it is. My intuition is that developing vaccines like this is very technical and difficult, and this is a new type of one. And whenever there's a new bit of science that's introduced, it's pretty much always in the category of like spooky sci-fi, and it gets used a lot by people who don't really understand science very well to explain a lot of different stuff, usually in the bad category, but also it can just kind of generally become woo. An example of this would be quantum. Quantum physics is like some bleeding edge science stuff, and people will invoke the word quantum to explain all kinds of things from spirituality to consciousness and all this, because it's kind of in that mystery, like cutting edge category of science. So we've got here some different stuff, but I wanted to go back first and talk about germ theory of disease, because the germ theory of disease is something that fundamentally it's tough for human beings, because we're medium-sized creatures relative to elephants and bugs. We're kind of in the middle, and our eyes and our ears can detect tigers, bears, lions, potential mates, food, danger, like a lot of stuff in our environment but we can't zoom in enough to see these bacteria and these viruses that affect us. And you have diseases in human history and likely prehistory, like the Black Plague and stuff, where people are dying in a huge percentage of the population, and people don't know what the heck is going on. So, do you know kind of some of the origins of that and how we got to even understand germs?
A little bit, yeah. Um, for a long time, throughout human history, as you said, until relatively recently, we couldn't see what was making us sick, let alone begin to identify it, understand it, um, and combat it. If you don't understand your foe, there's no way for you to defeat them. And so, for thousands and thousands of years, people did their best to chain together what observations they could make, and then they put it in the context of how they formed and retained and passed on information, and arrived at mostly all the wrong conclusions. So a lot of people believed, for example, in Europe, prior to the development of the germ theory, and some really classic experiments to prove it, that disease is caused by microorganisms, and not as opposed to the prevailing theory at the time, which was a bad air, a miasma. Malaria, for example, is basically, it translates to bad air. Um, so people were approximating what was actually going on because they thought, well, we can't see what's going on. We can't see the microorganisms. Not that they knew that they were there, but they had a sense that there were certain places that you could go and you would become sick, or if you were near a sick individual, um, you may also become sick. But they didn't understand the agents that were causing the disease.
Mm-hmm.
Um, and so it wasn't until the 1800s, uh, when people like Louis Pasteur and Robert Koch uh, really did some key experiments that more or less, for the time, were groundbreaking and um, really convincingly showed that um, there were microorganisms that could grow and replicate and propagate disease, um, as opposed to, like I said, bad air, or other theories where, well, if you have stagnant water, there are lots of theories around spontaneous generation. That's something about just water sitting still will eventually lead to um, the creation of life, that's small and can't be seen, and eventually that will give life to larger critters, and eventually you'll get to the point where you can start to see insects swimming around, or if it's a piece of rotting meat, you'll eventually see maggots crawling out of there, and you'll eventually see flies buzzing around it. But actually, understanding that the maggots and the flies were the same species, that the flies were laying eggs. That was all a mystery until you had things like microscopes, things like just the scientific process and that way of thinking and viewing the world.
So just because you can't see something doesn't mean it's not there.
It's yeah, short story long, exactly.
Yeah, well, that's it's an ongoing frontier. I think we're able to see now down past the atom. I don't know if we can see quarks yet. Maybe some other science people know that. What's the smallest thing we can see versus the biggest stuff that we've seen? But yeah, it's a really interesting process. And with this round of science, these vaccines are new. But first, I wanted to kind of get a sense of COVID first and why this has caused a pandemic globally compared to other stuff. Because we get sick pretty often with a bunch of different flus and illnesses and that kind of thing. And we've had pandemics in the past, but this is an event that has marked our generation as one of our trials that we've gone through and that we will remember for the rest of our lives. So why is COVID such a big deal? Why is it all over the world, and why does it spread so fast, and why is it so difficult to fix it?
Giving an exact answer will take decades of research to really understand on a molecule by molecule basis what is it exactly about this virus compared to any other coronavirus in nature. Why has this one, um, as you said, spread readily throughout the population, and why does this one cause disease? Um, what we know, at least now, is that, first of all, the virus does have the ability to attach to our hosts, to our cells, enter those cells, and then hijack the normal biology, the normal machinery of your cell to make more copies. And this is how every successful viral infection, it's a hurdle that every successful viral infection needs to overcome. Um, there's thousands and thousands of viruses that don't infect humans because they lack the basic biology to just even attach to our cells and enter them, let alone hijack the machinery.
Hmm.
So why this one? It's in some ways as simple as saying, well, it can, and that's why this one was able to enter into human circulation and wreak havoc. A few other things that it can do that plenty of viruses can't, and you would never hear about them because they never appear on our radar. It might infect one lonely person in some remote area, rooting around um, some unexplored territory or uh, getting too close to some kind of animal or another. And the viral infection there fails, never amounts to anything. But SARS coronavirus 2 um, does have the capacity to infect humans, as well as the um, animal species that it likely originated from, and we can get into that later if you'd like. Um, and then it also, like all successful human pathogens, it has ways of subverting the immune response. So any pathogen that could infect you but fails to do anything to temper your immune system is also just going to be a non-starter. Um, but to to everyone's dismay, SARS coronavirus has the ability to temper certain parts of your immune system, namely the ones that are really great at taking out viral infections. And it tends to exaggerate other, let's say, less helpful parts of the immune response. Um, so it overemphasizes parts of the immune response that, for example, damage your lungs, and it represses parts of the immune response that would be really effective at blocking the virus in the first place and clearing the virus once it's been infected.
So, if I can create an analogy here, just for layperson's understanding, it's basically like disease pirates get into the ship of your cells, they take control over it, and they make sure the door stays open for their buddies to come in, and they mess up a
Hmm.
bunch of your different settings and knobs to basically sabotage your system a little bit, but
Hmm.
enough that they can still survive. Because I think one of the things that I talked with Agent Smith about for COVID was it's a lot less lethal than something like Ebola, but
Hmm.
because of that, it's able to spread a lot further. Because if you're the disease pirates and you take over a system and you kill the host and you can't jump to another host, you're also doomed. So you would want to make sure that you're able to propagate and pass along somewhere else before your host dies. So COVID is less lethal, but that makes it a lot more contagious as a result.
Yeah, there's always trade-offs in pathogens. Um, I, depending on how you define a successful pathogen, the most successful pathogens are the ones that don't cause any disease, um, uh, but nonetheless replicate and spread. We can't really ascribe a goal or a personality to any one of these things, um, but if that's your definition of a good pathogen, then you wouldn't want to kill your host. That's your lifeline. Um, and if anything, you'd want to cause as minimal disease or disturbance as possible. So it's a good point. It's another reason why coronavirus has been um, a global pandemic. It it causes disease and it's a huge concern, but it doesn't immediately kill someone within, let's say, 24 hours, because that would limit its spread.
Mm.
And so these are all features that it likely evolved um, in another species. Uh, the jury is still out, I think, on definitively saying exactly where it came from, but uh, previous research on other related coronaviruses, pretty strong evidence would suggest that it came from bats, maybe directly jumped to humans, maybe went through an intermediate species, um, but along the way, it's developed or evolved all these characteristics that optimize its ability to replicate in the host and spread to a new host.
Mm.
Because a pathogen would eventually have to spread. Otherwise, the host will eventually die, and that's the end of the pathogen's history. Um, before I forget, I should mention another huge contributing factor here is that the novel coronavirus is novel, meaning no human, as far as we know, has seen anything exactly like it, which means you have 7+ billion people on the planet with no prior immunity, no protection to block infection, to restrict replication, or prevent spread to the next person.
Mm.
So it's a, a bit of a perfect storm of many different features. Um, but what you don't see are all the failed events, are all the times when humans encountered viruses, swimming in the sea, exploring the jungle, eating some strange new animal or plant, all the times that we encountered something novel, a pathogen that may absolutely wreck an elephant's day, but does nothing to us because the biology isn't compatible, and um, we just don't see or hear or read or learn much about that because it doesn't rip through our population and upend our lives.
Right. And the disease meta is basically evolving constantly. Like new forms of viruses and bacteria are exist coming into existence consistently, and this one basically had a critical effect on our species, and since we're global, it got to also be global as a result of that. But there are probably other diseases where someone catches it, but then their immune system figures it out and then kills it before they can pass it on, so it never makes the news, kind of a thing.
Hmm.
So this is one that pretty much snowball effect was compatible enough with us and spread easily enough that it was able to go around the world. And then that links into a question of how contagious is it? I guess what is the mechanism of catching COVID compared to other stuff? Like, is it airborne? I've heard the reason for masks, and this is a Bill Nye explanation. The reason of masks is to catch the water molecules that come out of your mouth and your nose, which the virus will be attached to, basically. So it's not just that breathing in the air is the issue. The mask catches the water, which reduces the chances that the virus goes through. So I would guess making out with people that would transmit it, uh, touching any like nasal facial opening and then touching other stuff, and then they touch that with their hand and then touch their face, that kind of a thing.
Hmm. Yeah, the virus, if anyone's had the incredibly unpleasant experience of having a nasopharyngeal swab, which is essentially a long, fancy Q-tip that goes in through the nose and then just about touches your brain. Um, it doesn't exactly, but it can feel like it. Um, this for a long time was this is the very back of your throat, way up in um, past your sinuses. So you can detect virus there. And so certainly anytime you breathe in or out, virus will pass that particular part. of the upper respiratory tract, but you can also detect equivalent levels of virus in the saliva. And so your upper respiratory tract, and to an extent the gastrointestinal tract, you can detect virus there as well. Um, so the good news is that it spreads through close contact. I think there's still a lot to learn about just how effective the spread can be, um, really in tiny, tiny uh, water droplets, aerosols that you generate naturally every time you breathe in and out. So the tiniest ones can stay suspended in the air. And if you have a room that doesn't have great circulation, let's say you walk into a closet and um, do a whole lot of heavy breathing and then walk out. If you're infectious and someone else walks in after you, how likely are they going to get it there? Um, Scientists are still trying to determine how much of that kind of quote unquote airborne spread explains the global pandemic. But
Hmm.
the best research we have, or the best data that we have, is that it's mostly spread through close contact, which is mediated by either direct face-to-face interaction, or these much larger, um, heavier aerosols that you would generate through that you generate naturally. You generate more when you're singing or when you're shouting, um,
Sneezing?
or when you cough or sneeze, right? And so these larger particles tend to fall at least after a few meters or 6 feet, which is where that kind of golden rule came from. But that's really not a golden rule. It's not like you're all of a sudden safe from someone just because you're 7 feet standing away from them. It's really just a guideline.
Yeah, the way that I have thought about it, some people have been kind of advocating against masks or the 6 feet, 2 meter rule because they're saying that it's not fully effective. But I see it as a way of just reducing the chances that it can hop from one person to another, where it's not going to be a bulletproof measure, but by wearing a mask, you're going to catch some of the water molecules, and by standing a bit further away, you're reducing that chance as well.
Exactly.
You could put a
And a cloth,
percentage to those if we could calculate it.
yeah. And people are trying. A lot of it, I think, is um, a lot of particle physics that I don't understand, a lot of kind of respiratory droplet modeling that I don't want to, so I don't want to put numbers on this. Um, but in general, a cloth mask will catch the largest of those droplets and reduce the most overt, obvious spread. If you are really sick and are generating very large droplets, you wearing a cloth mask will catch the largest of those and take out a good chunk of um, the chance that you spread it. And then someone standing 6 feet away from you, also wearing a mask, will have some degree of protection there to catch any residual ones. And then your level of protection goes up the more refined your mask is. So a surgical mask is going to do a better job than a cloth mask or something you made out of an old t-shirt. And then the medical grade masks are going to start to actually filter not just the uh, smallest of water droplets, but some of them, um, especially the kind of space suits that people might put on that have, a active respirator filtration system. These can start to actually block not just the smallest water droplets, but the virus itself, which is orders of magnitude smaller than the aerosols that you would generate.
Yeah.
But the model that I found really helpful to think about all this, and what I tell my friends and family is that any one of these interventions isn't foolproof. You have to think of it like a slice of Swiss cheese. So a mask alone is going to have some holes in it. 6 feet apart is going to have some holes in it in terms of the layer of defense, your layer of protection.
Hmm.
But if you start stacking up multiple slices of cheese, the holes usually after a while stop overlapping, and one layer starts to um, make up for the deficiency in a different layer.
So what you're saying is we
So
should use cheese masks instead.
that, and a built-in snack for the road,
Yeah.
biodegradable.
So I wanted to ask about this iteration of vaccines because it's an RNA vaccine and many people don't know what that means. I've heard rumors that it changes your DNA and that's very spooky. People don't want to be turned into different creatures. And then other people are like, hey, that's great. Can I have cat ears? So, what is this new RNA kind of vaccine? And then I guess just generally, what took it so long to get vaccines for this? Because it seems like the whole world was pointed at this. And I'm not saying that it's easy to do, but what is that process like of developing a new vaccine?
Vaccine development is usually a couple decades long process. If you think about when ideas and formulations are first tested in a lab, usually an academic lab, the conceptual groundwork is laid decades, sometimes multiple decades in advance. But then once it reaches the, I guess, industrial or pharmaceutical stage, it can still take around 5 years, sometimes longer, depending on how things go. It can still take quite some time to make sure that everything you're generating and putting in the vial is tested and safe, that you have no unknown entities in there, there's no contamination. And then it goes through multiple rounds of clinical trials. Um, and then finally it's deemed safe and effective because you need both to bring it to market. Because it can be safe, but it doesn't do anything, and the FDA will say, no, go home and try again.
But it could be
So
effective and not safe.
it could be effective and not safe, and that gets us to the idea of natural immunity. So you do generate an immune response if you survive COVID. And looking in the blood of people who have recovered, they have all the evidence that they generated an immune response. And there's pretty good evidence that that immunity is protective, that it will prevent them from getting the disease the second time around. But that would be, let's say, a less safe option than generating the same, if not better, level of immunity through a vaccine. I might be getting ahead of myself here, but uh, that would be, I think, an example of a method that is effective but carries significant risk. And if it were a drug in development, um, no regulatory body would approve something that had a 1 or 2% death rate, that hospitalized people, that caused these kinds of effects. Um, so it really, I would consider the journey from a brand new virus to vaccine delivery um, within a year as pretty remarkable. It happened much faster than I thought it would, and I'm amazed.
They've said that this one was rush approved by the CDC, where it was basically greenlit for emergency use, but usually they would test the long term effects of something for longer.
Hmm. Sorry.
So I'm guessing that's just
Yeah,
to
the
deal with the pandemic and whatnot, but under usual circumstances, it would be tested more.
right. Um, there's exceptions to the process when there's immediate and dire need. Um, I, I'm definitely not the person to ask about even the US regulatory code, let alone internationally.
Hmm.
But in general, this was remarkably fast, not only from a scientific and kind of technology development standpoint, but it was also incredibly fast from an approval standpoint. Um, but this is where I am not qualified to speak, but I do have sympathy and a lot of respect for people who need to take science and then make policy out of that. And they have to weigh the pros and cons of what the science is telling them with the pros and cons of the needs of a civil society.
Hmm.
Um, and here, personally, I um, think um, fast tracking approval um, did quite a bit of good. Um, uh, because the devastation that the disease was causing to hospitals, to commerce, to society in general, far outweighed, um, let's say, unexamined consequences. And I should note here that it's not like these were just totally untested. So the two brand new types, or the two companies that have made a brand new type of vaccine. These are the Moderna and Pfizer vaccines. They tested them in tens of thousands of people. So by a vaccine clinical trial standard, that's really large. So it's not like, um, they picked 20 college students and gave 10 of them the placebo and 10 of them this brand new vaccine that hadn't been tested before. It was like 40,000.
Hmm.
So it wasn't that it was untested. Um, but I do respect and understand people's concern when they say, well, what about the long-term effects? What happens 20 years from now? Um, and scientifically, I can't say, one way or the other. Um, but I would counter, what about the long-term effects of this disease? Um, and here's where, you have to make a risk assessment. Here's where you have to decide um, what's my tolerance for risk in terms of the vaccine versus the disease,
Hmm.
and then and we can talk more about this too if you want. More broadly, this isn't now my opinion as a scientist, but I take as a citizen. I have to consider what's my sense of duty or responsibility to everyone else in my life. Um, and am I willing to take a risk on their behalf as well? Um, because when an individual is vaccinated, they're not only gaining immunity for themselves, they're also doing quite a bit to prevent the spread of the virus. And we've already seen that as vaccine uptake has um, spread throughout the US, for example. Um, our case positive rates are plummeting. Will it stay that way? Can't. I'm not sure. But for now, the vaccines are having a remarkable effect on our ability to slow spread and contain the virus.
Hmm. Yeah, I'm thinking of the scene in Lord of the Rings where Theoden finds out that war is upon him and he has to choose what he's going to do with it. So, COVID is upon us, and you get to choose which route of risk that you take. But both sides have risk, and it kind of depends on what people want to take on as a part of that choice. So, one of the choices that people have taken is they want to not risk the vaccine because they feel like it hasn't been tested enough and they don't know what the science is about it, and it is putting something foreign into your body, and many people report side effects of their immune system coming online. Like I got the J&J on Friday, and on Saturday my body temperature was kind of up and down. I was congested and I had a headache. So you are, by getting a vaccine, signing up for maybe some unpleasant symptoms. You also get a poke in your arm. If you don't get the vaccine, though, you could get sick from it, and you could potentially spread it to other people. That's a risk that is a maybe. So some people would prefer to take the maybe and avoid the poke in the arm and whatever the vaccine has in it. And that's a personal thing. We all have to kind of bear the consequences together. And that makes it really tricky, especially when it's being politicized so much. I guess that's probably the frustrating part from your position as someone who studies this just as science, and that's kind of your bag, where a lot of people who know nothing about the science of germ theory or how vaccines are made and all this kind of stuff will be echoing really, really strong opinions about these different dangers and stuff. Like, people have joked about being able to mate with extraterrestrials by having the vaccine and stuff, and just all the different spooky factors involved when we've had pandemics before and we've had vaccines before to deal with stuff like polio and measles and things like that. And I would guess that during those, there were people who also chose to not take the vaccine because they would prefer to risk the maybe instead of the sure poke in the arm.
Yeah, enthusiasm for vaccines or medicine in general, has always enjoyed its ups and downs. Um, Conspiracy theories are um, readily spread in the modern era, but it's not like it's new. Um, Something about American culture for hundreds of years has always fostered plenty of conspiracy theories. So, how any of us, not just scientists, but how any of us in society agree on some shared principles or shared data or facts, and then make decisions for ourselves and each other based on that. Um, that's kind of the whole experiment that we're in here, at least with democracy. Um, and I don't have great idea or great, solutions to that. I will say that the harebrained ones make me laugh. But I do want to be fair and I do want to respect people who are scared, because I think people who are afraid of something new in medicine, um, in some cases I can respect it, and I want to say that they have every right to their emotions. Um, and there's, for example, plenty of historical reasons why people would distrust physicians, why people would distrust medicine, why people would distrust a particular vaccine. Um, but what you then do with that really can change your life, especially if you happen to get sick and have long-term consequences for it. Or you spread it to someone and give them a set of consequences they didn't want to deal with,
Mm.
or potentially kill someone. You may not even know it. Um, so I don't want to say I get too frustrated with people who are hesitant, um, but I do try and do my best to hear them out, address their concerns as best as I can from my either personal experience or my years of study.
Mm.
But ultimately, I know I can't control someone. I can't change their mind, and they have to do that ultimately for themselves. Um,
I've noticed, and this is something that Agent Smith and I talk about pretty often during world discussion, is during different time periods, you have a different culture for how intellectual or how skeptical society is regarding changing your position and putting faith in science and research and that kind of thing. You have periods like the Enlightenment, where there was a huge focus on just doing research, funding research. It was like a hobby for a lot of people to bankroll a young scientist and say, yeah, I'll pay for you to go to this school,
mhm.
whatever, make some cool invention that I can show off to my friends. And that was like a stylish and cool thing to do, to just be involved in science and to see the new zany stuff that was coming out. It seems like for a lot of people, we're kind of in an anti-intellectual period where it's more about the strength of your convictions and really believing in something and sticking to that, and that's what's seen as strength. I think that's the assessment you could make: is, do people value your loyalty to a given kind of idea or team or political party or whatever, or do they value your ability to admit that you're wrong and change your position? That would be valuing skepticism, because being skeptical and being flexible, it can be seen as weakness to some people, to that you didn't uh, believe in your ideas enough. That's why you failed or whatever. When I think admitting that you're wrong about something is one of the best ways to not be dumb over the long term, because you can receive information. I had a formative experience in university where I had a professor in a psychology course who gave me some wrong information, and I found out from a fellow student that it was wrong, who was taking a different class that had some different outcome. I think it was whether or not IQ was a heritable trait at all. And this professor was saying, he cited one study and said that there was no correlation between one generation and another generation. And it was more about like that case study. And then I talked to a friend who was taking a genetics class, and he was saying, no, it's heritable. And then he just told me what the decimal point was for like what percentage it's heritable. And I was like, what? That's not true. Because I believed my professor. So a lot of people, I think, they put that faith, they put that trust in someone who is an authority. They do have a degree, they do have a PhD, and they assume that they're going to be able to be correct about whatever they talk about. That's a really tricky aspect of the marketplace of ideas. Is being an expert is kind of a lifelong pursuit, but even then an expert can be wrong. So you have to put faith in something. Either you're putting faith in your immune system, in this case to fight off COVID and for you to survive, or you're putting faith in the scientific method and the researchers who are developing these vaccines, that they're good enough and they do what they are meant to do. So there is a lot of faith and trust that we put in, because most people aren't going to read all the fine print of each vaccine that's made. They had this fact sheet for me whenever I chose which vaccine I was going to take that said what the side effects are and just a bunch of info about it. I didn't read the whole thing because I put some faith in the scientific method and the people who are making this vaccine, that I think that I have a good chance of surviving this vaccine. I'm feeling pretty tough. I feel like I could just get COVID and get over it as well. But if I get the vaccine, I have more travel access. I can go more places. It also probably reduces the chances that I get it and pass it on to someone else. And it wasn't that inconvenient for me to go get it. So that's my personal choice. Everyone gets their own choice in this. I think some places, there was someone in chat saying in Israel you were required to get it. That's interesting.
I don't know. I know that Israel had a fantastically successful vaccine program, and they managed to vaccinate huge numbers of people every day. But I don't know what the requirements were. There are ways of inducing people to accept it. Earlier some people in chat were joking. More along the lines, one way to do it would be to pay people. If a country had a stockpile of vaccines, for example, and offered vacation packages where you could stay at an all-inclusive resort and get the vaccine, you happen to live in a country where you didn't have access to it yet, it's a way to induce someone to do it. Some people, the reward is fulfilling their own sense of security, as well as fulfilling a sense of civic duty, that they'll do everything that they can to protect those around them. But other people might need other inducements, and I will admit my ignorance here. I think that's a great question for Agent Smith, who might have some ideas about the economics of or a reward-based system for something like vaccines.
It's making me think of in our WoW guild thinking about rewards for stuff and how that's very controversial in its own right, because then all the people who already got the vaccine are like, hey, why don't I get the $20 Starbucks gift card or whatever they would end up dealing out for that. But yeah, it's
I think ultimately what this will come down to is there will be certain places, likely, as there are now, that are certain places that you can or can't go, or certain activities that you can or cannot participate in unless you're vaccinated. And this is already the case for travel. If you want to enter or travel certain countries, you need to have proof of immunization against certain diseases. If you want to attend public schools, if you want to go to um, camps, so this is like already true for lots of kids in their programs. If you want to go to university, you have to have a certain degree of immunity um, to a battery of different pathogens. And the reason why those pathogens aren't still causing global pandemics and uh, continued misery is because we developed vaccines to them, stopped the spread, and prevented disease.
Mm-hmm.
So these are sort of indirect ways that people who don't want to get vaccinated to coronavirus right now are quite upset about. They don't want to feel like their actions are restricted. Um, but what I wonder is that do they not realize that this is already a system in place, not just here in the US, but around the world. There are certain, suppose, bargains or trade-offs that you make in order to participate in society. Um, and we have decided in the modern era that being vaccinated and not being an incubator or petri dish for lethal disease is one of those uh, things that you do in order to participate in a social society.
Mm-hmm. If you had people who were skeptical of taking an RNA based vaccine, what would be the explain it like I'm five
hmm
for why that's not really a scary concept?
So this is a good place for me to also mention before when I said vaccines can take decades sometimes to develop. Um, it means that the basic research, the fundamental understanding that we have of each of the components of a vaccine, and then how each of those interact with the immune system to generate immunity, these are ideas, research questions that had to be fleshed out. Um, in some cases, yeah, for decades. So a lot of that groundwork for the RNA vaccines was already laid, and it's how we managed to produce one within the span of a year. It's because scientists had already been researching what RNA is. People had already been researching the immune system and defining the parameters of the immune system that correlated with protection to a disease or correlated with um, an adverse event or an adverse reaction. So all of that was already kind of set in stone. Um, and then from there, it was a matter of relatively quickly building on that and taking the next step forward, the next intellectual and technological step forward. So my first thing I would say to someone is that this is not brand new. This is not a totally unknown, untested entity. There's decades of research, and I would guess since the 70s, millions of scientists who have thought about RNA and have thought about the immune system and have thought about viruses. So you have all the weight of you. A phrase in science is we stand on the shoulders of giants. And I think the public benefits from that as well. You have this ginormous foundation of knowledge that backs up an RNA vaccine, and then you get to reap the benefits, stand on the shoulders of a giant, and see just a little bit farther, see just a little bit more of the horizon or um, the next achievement. Or if you just want to get vaccinated and kind of go back to a normal life, what you see there in the distance is hanging out with your buddies at the bar. Um, so that's one thing I would say. The other thing I would say is all of the main component of these RNA vaccines um, is RNA. And for someone who doesn't know what that is, it's a molecule that every living organism on the planet produces. This is the way that the information encoded in your genes is, uh, I suppose, um, the way that the information is read and dictated to all of the other molecular machines in your cell and all of the cells in your body. This is how the instructions are read to the body, and this is how the body accomplishes just about any task. And so you produce an RNA to eventually build muscle proteins when you work out. You produce RNA when you are learning, and the neurons in your brain need to make new connections. Fundamentally, a part of that process involves RNA. So in this case, instead of using your own RNA, your own instructions, what the vaccine does is it has designed RNA that will read out instructions for a piece of the virus. And this is a way to safely introduce your body's immune system to a piece of the virus, which is the first step in generating immunity, without suffering a full-blown infection with the entire virus and all of the disease that might come with it. Because we talked before, um, one of the things that makes this a successful pathogen is that it has evolved its own ways of subverting the immune response, of suppressing the immune response in ways that allow it to be a successful pathogen. An effective vaccine in this case wouldn't be to um, or an effective way to generate immunity wouldn't be to just get the whole virus and deal with all of those consequences. It would be to take just a piece of that virus as a way to introduce the immune system to it, generate immunity such that you're protected from the infection without getting sick. Um, and in some cases, according to some recent studies, the level of protection that you generate from a vaccine versus uh, the immunity that you would generate from actually getting sick, in some cases is equivalent, and then in other studies, it's higher. The vaccine generates 10 times more um, antibodies, which is we can talk about that, but it generates a greater level of immunity um, than you would from getting sick and recovering from COVID.
The way that I'm thinking about this is you're giving a dog the scent of something and you're letting that dog know this is a bad man and you need to go
Mhm.
find out where this guy went, and your immune system can then identify it whenever the bad man shows up and then knows that that's a threat and not someone to play fetch with, kind of a thing. But it seems like to our immune system by default, uh, because it weakens it, people are less effective at identifying that and then fighting it off in a timely manner, which is why people in certain risk groups, elderly, overweight, pre-existing respiratory issues are the ones that I know of, have
Mhm.
a much greater chance of having further complications with it. That's a tricky thing too for people. Like for myself, I don't have any of those complicating factors. So for me, getting COVID is very low chance that I would die or something. But a lot of people are getting the vaccine or they're quarantining because they don't want to put the people who are in those risk groups at further risk.
Right. It's not that someone who's young and healthy is never going to end up in the hospital or die from coronavirus. It just means that you're less likely. But again, that's quite the risk. It's the comparison I like to think of is wearing a seatbelt. Um, if you're in a car crash, let's say it's a kind of a fender bender, you're going pretty slow, you're more likely to hurt yourself if you don't have a seatbelt on. So putting a seatbelt on is a simple way of reducing the risk of injury. It doesn't completely protect you. It's not like you're immune now and you can, you know, crank down the highway at 190 miles an hour. Um, but you are less likely uh, to suffer in a crash.
Mm-hmm.
And I think the same is true with um, getting coronavirus. It certainly has a much more severe impact on people with weakened immune systems, as most diseases do. And in general, I would say people with a lot of cardiovascular problems. So that can occur naturally as we age. That can occur from things like diabetes, or obesity, can happen if you smoke, if you have really poor habits like excessive drinking or other substance abuse. Um, so certainly those people, I would hope, would want to take the vaccine and do what they can to protect themselves because they're at increased risk. But just because you think you don't have any of these things, doesn't mean that the virus is going to give you a cold, or a rough week and then you recover.
Mm-hmm.
Um, what makes this, I think, scary to a lot of people, and scientists included, um, is that we don't know the long-term consequences of disease and then recovery. Uh, but it already looks like this virus can leave people with certain scars, let's say, that other, let's say, respiratory diseases like flu don't necessarily, or are far less likely to. So one of those things has been termed long COVID, where people will recover, but never fully regain um, their former energy levels, their ability to even think clearly. There's this like cognitive defect that people will report. Just like when you have a really bad fever, you're not thinking clearly. You know, uh, and people who recover from COVID and have this syndrome called long COVID experience very similar symptoms, where it feels like they're still sick, even though they've gotten a little bit better.
Mm-hmm.
And when you look at the immune system of these people, at some point during the course of their infection, uh, some of them manage to generate what looks like an autoimmune disease. And what it is about coronavirus and the disease that it causes that this um, leads to this, I guess, mistaken response by the immune system. We don't know the answer to that yet. Um, but that'd be another risk that I personally wouldn't want to take. Um, Even though, like you, I think I'm probably not in that high risk category. Um, but one, I don't know if I'll be so lucky, if I'll be one of the unlucky few who are young and healthy and have no other underlying conditions and yet still manages to be hospitalized or still may die. I don't want to take that risk. Um, and if I do recover, why would I risk potentially a lifelong debilitating disease?
Mm-hmm. So I wanted to segue into the next kind of question, which I think was the thing I mentioned whenever you piped in chat and said that you'd be keen on talking. Herd immunity. What is herd immunity, and can we get it with the vaccine and stuff, or people getting sick and getting over it? From what I can understand, there's like some critical mass of if we have enough people who are immune to it, then the virus can no longer spread from host to host very effectively. So it doesn't have this kind of pandemic effect of infecting a lot of different other people. Maybe the odd person gets sick here or there, but that would probably be the masks off win condition for us.
Yeah, that's very well said. Herd immunity is this kind of funny term of art that maybe fairly or unfairly treats humans like a big pack of animals. We kind of are, but the idea is exactly as you just said. As more and more people are immune to a particular disease, the pool of susceptible individuals decreases, and you get to a certain point where even if there are a few susceptible individuals left in the herd or in society, they never come in contact with each other because there's this huge group of immune protected individuals surrounding them. So you can kind of think of it like 7 degrees of separation to your favorite celebrity. Um, we're all linked to each other one way or another, and with international travel and plane rides, we're much closer to each other than you may think. So if let's say I go out and I get a drink from a bartender. We're in an enclosed space. We chat for 20 minutes, no masks. Um, if that person is transmitting virus, but I happen to be immune, I now protect the next person who would be otherwise 1 degree separated from
Hmm.
that spreading infected bartender. I hate to pick on, one particular profession. I don't mean to. Um, but that's how ultimately herd immunity does work for a lot of diseases that we have successful vaccines for. And someday we may achieve that with coronavirus, although I think a lot of scientists and policymakers right now are hedging their bets and saying that it will either be very far off or impossible.
Why?
And part of that has to do with the race between the humans and the viruses. So right now, we are generating immunity one way or another, either people who get sick and recover or people who get vaccinated. But that immunity is really only effective and tailored to the virus that infected us. And what happens in any arms race or any evolution is that there are competing sides. And when one side figures out a successful strategy, a meta, the other side will figure out ways to exploit that or subvert it. And that's what's happening with the virus right now. So the immunity that was generated globally and is continuing to ramp up has put what's called a selective pressure on the virus. So now if a virus is replicating in a host, there's a certain degree of random mutation of mistakes that are made as the virus replicates. And that's what gives rise to subtle variations between each each new virus. Um, and some of those variants are terrible. They're completely failed attempts and they don't go anywhere. Some of them are pretty much exactly the same as the parent strain, the original one. And then some of them are new and new enough that when they reinfect an immune individual, the pre-existing immunity is no longer as effective. So here's where we can go back to your kind of bloodhound example, where if you give a dog a certain scent, beware of anyone who smells like this. What if that person comes back a day later and is just doused in stinky, stinky cologne? It might mess up the dog's ability to recognize that person. And so the virus can more or less do this on a molecular level.
Hmm.
One of the ways that your body generates immunity is by producing these proteins that kind of percolate through your cardiovascular system, percolate through your tissues, like the lungs. These things called antibodies. And antibodies are these little molecular magnets that will stick to the outside of the virus and block that virus's ability to attach and enter your cells. Put another way, to block infection. But the way that the antibody sticks to the virus is based on shape and charge and physics. And so if the virus devises a way to mutate such that the physical surface, the kind of physical, chemical, electrostatic surface of the virus is now just different enough that the antibody doesn't bind as well, it doesn't stick as well, it doesn't block as well. Well, now you have a new variant that evades pre-existing immunity. And that's what's happening. A few of these were discovered last year and have since spread, and in some places, the new variants, it's still SARS coronavirus 2, but they're different flavors. So these new variants have started to become dominant. They're replacing the original strains that were circulating and are now the ones that are leading the new infections. And so this is why achieving herd immunity may not be possible. If we were able to isolate absolutely everyone on the planet, put them in quarantine for 2 weeks, we might be able to eliminate the spread of coronavirus without any vaccines. But that first strategy is impossible. So the next strategy is vaccinate as many people or generate immunity in as many people as possible and as quickly as possible before you allow too much time to pass and too many variants to achieve that immune escape, um, and to circumvent the immunity that we're trying to build with these vaccines. Um, so I don't know the answer. Ultimately, is herd immunity possible? Will we ever get there? I'm really not sure. Already, we know that antibody responses that were generated either from people who got sick or people who got vaccinated, those are already less effective at uh, preventing infection and possibly preventing disease against the new variants.
Yeah, there's a friend from chat, Flying Dutch Kid, who has gone through medical school, and he is saying the most likely scenario is a yearly or 2 yearly vaccine in perpetuity, like influenza. So, like
Hmm.
the seasonal flu shots that they recommend and often provide at grocery stores, I guess would be the similar approach to that, because coronavirus is a flu type. Is that correct?
Yeah, I would say in terms of its taxonomy, what um, it's more related to things that cause the common cold. But in terms of disease and spread, um, misery, and yes, the potential for seasonality, I would say it's more akin to flu in that way. But on a strict familial basis, it's more related to viruses that caused the first SARS coronavirus that spread mostly throughout East Asia, and then the MERS virus that spread throughout the Middle East. So those are its closest cousins, and those, like this one, caused serious disease and death. But yeah, your Flying Dutch Kid is absolutely correct. One possibility here is that it becomes seasonal, or that we need booster shots, slight modifications to each annual or biannual vaccine that allows us to catch up to whatever new mutations the virus has figured out.
Mm-hmm. Yeah, get your firmware updates. Get
Yeah,
your virus updates, fam.
yeah. I mean, ideally, that wouldn't happen. I think most people would like that. But this gets back to mm, public trust, what kind of society we actually live in versus what kind of society we would ideally like to live in. Um, a lot will depend on human behavior. And ultimately, that's how this virus spreads, is human to human contact, human behavior. Um, the virus by itself has no objective or motive. Um, it's really just a very fancy clump of genetic material, proteins, and fat.
What's
It's just
objective
doing
is to
this.
propagate itself.
Exactly.
Yeah. To swarm, basically.
Yeah.
So it seems like a win condition is being able to have a lot of these, I guess, precautionary measures that we've learned from this pandemic. Those would apply to other future diseases, because I don't think there's been a disease that became this global this fast. This is like the first, at least from what I can tell, truly international kind of all at once thing. You've had, I guess, polio outbreaks, or what else has there been that's been really intense for the whole world? It's just the travel that's available
Mhm.
to the common person now is so easy. You can fly to another continent at a moment's notice, pretty much, which means that if it spreads somewhere and it's contagious, it's going to spread everywhere. So we've learned
Mhm.
how to social distance. More people have a mask in their just wardrobe than they did before. A lot of countries in Asia, I think it was more commonplace when you were sick, you would
Mhm.
wear a mask just as a etiquette thing. That's
Yeah, but
not common practice in the U.S., but maybe now it will be.
it might be. My understanding is the widespread use of masks in East Asia was a result of their scares with uh, SARS-CoV-1, coronavirus 1. We're dealing with 2 right now. Um, uh, as well as probably also some recent outbreaks of things like bird flu that spread by poultry or migratory birds, and then jumped into humans and again caused a lot of hospitalization and death. So I think I would, um, my guess is that for a lot of people, this will change their behavior, at least in the short term. Maybe 50 years from now, if we happen to really kick this thing's ass and things go really back to normal, maybe we'll all forget about it. Someone, I'm really terrible about talking and reading chat at the same time, but I did see someone mention Spanish flu. So this was the 1918 global influenza pandemic that did spread around the world, not quite as fast as coronavirus, but caused the worst outbreak of disease in the States that had been seen in quite some time. And yet somehow, a couple generations later, we don't exactly live with that legacy. There are
Hmm.
different pandemics. There were very different times. War and threats of jailing reporters definitely kept information from being spread quite as disseminated quite as it is today. So to name a few things, they're very different global pandemics. But it does make me wonder how much it really will stick with us generation to generation. One thing that's likely not going away, though, is the infrastructure that's being built up to support the mass production of all the vaccines, but especially the two brand new ones, the ones that are based on this RNA technology. And what's nice about this particular technique is that it's much faster to modify an mRNA vaccine than it is any of the other previous technologies or strategies to vaccinate people. So before it was thrust in the limelight as a coronavirus vaccine, the idea of an mRNA vaccine was being developed for other kind of common viral infections. I believe things like cytomegalovirus. So the idea here would be you can easily adapt the mRNA, and instead of having it provide instructions to the immune system to go after a coronavirus spike protein, what if you shifted that to HIV glycoprotein? What if you developed one to uh, recognize polio? What if you developed it to recognize cancer or your kind of personal cancer? If there's an identifiable target in there that would be safe for the immune system to um, recognize and respond to, the technology and the theory behind this is incredibly powerful. And it's the ability to modulate and adapt these vaccines, make it ideal for dealing with, let's say, coronavirus that is mutating right now and generating so-called escape mutants. But it's also brilliant and relatively simple to adapt the idea to treat a lot of different diseases. And so the production that we're ramping up right now to generate, billions of doses of mRNA vaccines means that we'll be left with that infrastructure and delivery system um, to maybe do a lot more good, um, either in the next pandemic or to address diseases that um, we haven't quite yet cracked yet.
Yeah, so this is a new technique, and someone in chat was saying that this isn't the first time we've used this mRNA tech. It has happened before, but this is like the big one that people are familiar with because COVID is a global thing.
Um, have not seen the comment. I'm not sure if they mean um, to the level of clinical trial and public use, or if they mean tested in a lab or in an animal.
Mm-hmm.
So it's certainly not the first time that it's been tested in a lab or put into lab mice, for example. At least to my knowledge, I had thought this was the first clinical trial for an RNA vaccine, but I could easily be wrong.
Mm-hmm.
It may have been tried. I have a vague sense that possibly Zika. people may have tried developing an RNA vaccine for to use to control Zika outbreaks. Because again, this was a novel virus, no prior existing immunity, and very easily spread. This time by mosquitoes and not person-to-person contact, but nonetheless a serious concern. But I could be wrong there, and if there's someone out there or in chat who knows better, I'm happy to learn.
Do you know what CAR-T therapy is?
RT therapy. This is a not a vaccine per se, and it's unrelated to the idea behind an RNA vaccine, but it is another ingenious strategy that harnesses the power of the immune system to uh, clear things like cancer. So the immune system is really exceptionally adept at um, targeting very specific things like one particular protein on one particular virus, and then eliminating it one way or another from the body. And CAR T cells take advantage of the immune system's ability to recognize specific entities and directs it instead of against a pathogen, instead against something else that is undesirable or let's say doesn't necessarily belong in the body, and that would be a cancer cell. And it turns out that some cancers are sufficiently different enough from the surrounding healthy cells and tissue that you can generate an immune response and eliminate it. And CAR T cells is a really refined therapeutic way of doing that.
Hmm. It's interesting in both this CAR-T and the mRNA, you're using the immune system to do the work. It's not as though you're introducing something that goes in and it fights the virus within you. It basically goes in and it helps point your own immune system to defeat whatever you're faced with. In the case of the CAR-T, it would be the cancer cells. Yeah, the immune system seems like a pretty powerful setup you've got. And things like allergies, this is maybe veering a little bit off topic, that would be your immune system acting up in error to the wrong stuff that maybe you wouldn't consider a threat to yourself, but it gets activated. So it's not perfect in the sense that it doesn't always know what's good and what's evil. It's strong and it can be pointed at stuff. And a lot of this vaccination is about training that to fight certain things.
Right. But with the trade-off that the immune system can be mistargeted or misdirected, um, or the response may be so destructive that your normal, healthy neighboring tissues or cells are destroyed or compromised in the process. And so this is where I think a lot of people will assume because they're healthy and they have, quote unquote, a strong immune system, that they can't get sick. But you should keep in mind that a lot of, especially the lung pathology that you see in patients with severe COVID, that's immune generated. It's consequences of a mistargeted, misdirected response.
It's like when
And
there's a bug
here's
on you and you end up slapping yourself in the face instead.
exactly, but at least a slap is the appropriate response to a bug. In this case, the analogy would be a bug is on your face and you shoot your hand.
Ouch.
The immune response, when mistargeted and not the right, not the appropriate flavor of response, it can really cause a lot of destruction. And this is what we see over and over in patients with severe disease, or patients who succumb. It's not that they generate no immune response; it's that it's the wrong kind. And so uh, the lungs are compromised, and if the vascular barrier in your lungs starts leaking and your lungs fill with fluid, you don't breathe so well, and
Mm.
that's a problem. So this is um, something that, especially with the new pathogen, sometimes can be hard to know before you study it. Um, and in some people, it can be hard to predict. So, um, and I think allergies, and then there's allergies, and that's kind of a whole other can of worms. Because I think one way that most people think about it is that all allergies are entirely inappropriate, and it's always an immune mistake. Um, but I'm not really sure about that. And I think a more nuanced way to view something like allergies is that there's something about the immune system that we don't understand, because allergies don't just we don't evolve things just to be a mistake, especially if it's a lethal mistake. If you eat a peanut and you die, that's not something that's evolutionarily beneficial.
Hmm.
I think our understanding on you know these kinds of questions are always very difficult for scientists to address, but I'll pose it anyway. Why we have allergies. Um, I don't know if there's a strong evidence-based consensus about that. The kinds of responses that look like allergies are really good at clearing worm infections. So the kind of immune response that you'd want to generate to deal with a virus is very different than what you would deal with a worm. They're totally different organisms, and they're orders of magnitudes in size difference. So a virus you can kind of directly kill, and a worm you have to get a little more creative to eliminate it from your body. Um,
Hmm.
So all of those kinds of immune responses that you would generate against things like worm infections, they look a lot like allergies. Um, Sneezing, coughing, diarrhea, so-called expulsion. If you're spewing from both ends, it's a great way of getting rid of huge parasites. Or if you're itching, if you're scratching your skin, it's a good way of getting rid of insects or other parasites that are trying to colonize you. So that's all kind of makes sense. Why you generate all those immune responses to pollen or peanut, I'm not so sure it's a mistake, but um, I don't want to get too into that. Maybe that'll be another topic for
Hmm.
another day, because that's a whole other um, set of cutting edge science and immunology theory crafting.
There was another question about the new vaccines. Is it the DNA markers on the surface of the cells that trigger the immune system? Are these markers the same for different varieties of COVID, and would that make the vaccines effective against all of them?
Mm. Um, one one thing to clarify, DNA is the genetic information that would be inside of your cell, specifically inside the nucleus. So it's really kind of cornered away in one particular part of the cell. So it shouldn't be on the surface, and if it is, you've got problems. But what the immune system is recognizing in the case of coronavirus is this thing called the spike protein, and it's a molecule made of amino acids, so therefore it's a protein. Just to kind of categorize it and make it, the terminology makes it distinct from DNA, which is made of nucleic acids. And this protein is what allows the virus to attach to a protein on your cell. And it's through this interaction between the two proteins, one on the surface of the virus, one on the surface of the cell, that allows the virus to stick and eventually enter the cell. And then an antibody that the immune system would generate um, in response to that virus infection is going to interrupt that entry process. It's going to get in the way and block it.
Hmm.
So in this case, what the immune system is recognizing is one viral protein. Depending on how closely related, let's say, coronavirus spike protein is to another virus's protein that's displayed on its surface, you can sometimes generate immunity across multiple different pathogens or across multiple different strains. Um, the bad news here is that, as far as we know, um, pre-existing immunity that people had from, let's say, getting the common cold, it doesn't really do a great job of seeing the new coronavirus.
Hmm.
So while an antibody, and and by proxy, I guess say the immune system can sort of see this new coronavirus, it doesn't really do it very well. It's a very hazy representation. And for all intents and purposes, it's pretty much blind to the new virus because we know that um, any kind of pre-existing immunity that you might have generated from, let's say, the common cold, confers no protection to um, when you're infected with the new virus. Does that? I hope that answers
So if I
the
can make
question.
an analogy to put this in simple terms, the spike protein is kind of like the horns coming off of a creature, where it has
Mm.
some representation of their composition, but it's not at the core of like what's in the middle of it. It's more on the outside. And the question is, would the horns of this coronavirus vaccine be the same as the horns of another mutation of it? Would the immune system look at both of those and say these are the same thing and then attack the new one? I guess we don't
Hmm.
know until it's tested.
Yeah, and people have been working furiously on this. In the major journals just last week, there were a half dozen or a dozen papers just exactly addressing this question. So some, as I mentioned, some, viral mutants will kind of modify their spike protein, and they don't really matter because the immune system can still recognize those variants and do a great job of preventing infection, helping to clear the infection if it does happen to take root, and ideally preventing spread. But every once in a while, there's a fundamental enough change in that spike protein that the immune system is really on the back foot, is now at a disadvantage in terms of its ability to recognize it. And on a molecular level, when I say recognize, what I'm actually referring to is the ability of the antibody to physically attach to and stick to the viral spike protein.
Mm-hmm.
And so um, it's not that the spikes are completely different. An analogy here would be maybe they change shape just a little bit. If they were a little bit twisty before, maybe they're twisting in the other direction. They're clockwise before, now they're counterclockwise. And it's just enough that the pre-existing antibodies can't quite get the same grip on it. They can't quite grasp onto it.
Mm-hmm.
Or the analogy of what the immune system can see. Um, Before the spikes were red, now they're pink. Now the immune system isn't quite sure, wait, are these the same thing? Am I recognizing what I was before, or is this somehow different?
Mm-hmm.
And with the new variants that are spreading all over the world, some of them are of more concern than others because they're so effective at evading those antibodies that people worked so hard to generate, either from getting sick and surviving or from getting vaccinated. And that's a problem. If the immunity that you generated is now, I don't know, 50% as effective, well now the question is, okay, am I going to get sick now? If I was a little unsure of my ability to prevent infection to my friends and family, now I'm, really questioning that. So we may go back and forth for a while between vaccinations, between or rounds of vaccine, um, periods with masks, without masks, with social distancing, without. I'm not really sure from a policy standpoint how this will play out. But the reason why the situation on the ground will seem like it's constantly changing, what's behind all that will be these mutations, these variants that um, figure out a way to escape the immune system while also retaining their ability to infect you. Because that's the trade-off the virus is making as well. It can generate all kinds of wild variants, um, but a lot of them are just going to be completely broken. Just like there's a lot of build orders in StarCraft, but a relatively, few number of them are actually viable. So the virus is also, evolving against that backdrop.
Okay, I have a really shitty MS Paint thing that I'm trying to use to think through this and the mechanics of how this works. I will show it on screen. Brace yourselves. Okay, this green thing here is a cell. It's one of your body's cells. And these little, looks like a nail. This would be coronavirus. And what I'm understanding here is that the vaccine or your own sickness teaches your immune system to put something that blocks whatever the like attachment process is to your cell. So it prevents the Rona cells from being able to sabotage and take over your own cells. And the question we're asking here is, as the viruses adapt and mutate, will this same immune system response block whatever this heckin' spike protein is on the Rona 2? Or whatever new virus comes up.
Yeah, that looks good to me.
Thank you.
That's, I mean, that's more or less the kind of schematics that we draw in our textbooks. There's a few more details, there's a few more 3D graphics or whatever, but that's basically the idea.
Okay.
But here I should say it's they're flavors of Rona. It's not an entirely new virus. It's um, you know, a virus with just a slight change. It's like picking Neuro's color, changing it from yellow to green to brown.
Hmm.
And once you start getting into some of those darker colors, you can't see your creep tumors anymore. Um, and maybe that's another and possibly unnecessary additional analogy. But it's similar to what the immune system can readily recognize and deal with, and what adaptations lead the immune system to fall apart a little bit. And I'd say the difference between a green creep tumor and a brown or dark purple one would be another kind of analogous scenario there.
Mm-hmm. Thanks, antibodies. So I had a pretty easy, I think, response to the vaccine. I just had 1 day of effects. Took it on Friday. If anyone wants to see my personal notes of my experience, I put them in the Ask Neuro chat in my Discord. But yeah, it's a big question, and I'm glad that I got to talk with someone who is learned in this particular field, because I've had a lot of people with very zesty and spicy, very politicized opinions on the vaccine and the virus and what we should do. And it is really the big crisis of our time. I think for people who are Zoomers or millennials, or maybe even the next generation up, I don't know if there was a huge global event that we all share and try to survive together. It definitely is a difficult one. It's impacted a lot of how we feel, because we're social creatures, and isolation and quarantine is oftentimes considered a form of torture. It's kind of been questioned that if you put a criminal in solitary confinement, is that torture? We're self-imposing isolation to prevent the spread of this kind of disease, and that ends up causing a lot of frustration and anger. So I can see why people would be worried, skeptical, and just generally speaking, grumpy. So it's really awesome to talk to someone who studies this stuff. Thank you, Sir Will.
Thanks for bringing me on. And I agree, it's not easy making societal level decisions. Um, Even with my scientific background, I'll just say again, at the end of the day, I make decisions based on my understanding of the risk, what I'm willing to tolerate, and what I feel I owe my fellow members of society, people I've never met before, and people I care, deeply about.
Mm-hmm.
Um, and so I'll say I got vaccinated. I had the Pfizer one, and I weathered a day or two of slight discomfort for the peace of mind that um, I wouldn't be the start of some family's catastrophe down the line. And I've read about and I've studied and handled and studied actual patients and seen enough from my experience to know that what I was taking on was worth it. And I hope that people can figure out for themselves and rely on, I would say, the best information that science can provide, up to date, and make the best decisions they can.
Conclusion, Corona bad. Confirmed. I agree with that. It's had all kinds of different consequences for us. Question for you, can I pass along questions from the YouTube comments to you? People have things they want clarified.
Yeah, absolutely. We can, I'll figure out a good way to respond and get answers back to folks. For anyone who's stuck around this whole time, this is me. So if people want to find me on Twitch, they can.
Sir willblur.
I'm willing to answer questions.
Will the blur. He's doing science so fast you can't even see him. He's just a blur. Let's see, remember it.
Yeah, I like it.
We talked Knight's Tale because I was looking for a semi-anonymous tag for you, and Sir William came to mind. 2001 Heath Ledger movie, very good film. Thank you for taking a break from your jousting and talking with us about jousting against coronavirus, sir.
Very welcome. Thanks for having me on. It's been great chatting with you.
Hell yeah. And thank you, chat, for being pleasant, and moderators for keeping things at a reasonable level. Well, take good care of yourself, and we'll see you in the YouTube video, dude.
GG.
Take care. Swarm them.